Hi everyone, myself Divya is studying in Sri Venkateswara College of Engineering. Today in this video, let us discuss about the topic Border Gateway Protocol in Computer Networks and from the subject Computer Networks. Border Gateway Protocols in Computer Networks. Introduction to BGP. Border Gateway Protocol is a standardized exterior gateway protocol. It is used to exchange routing information between autonomous systems. BGP is crucial for functioning of the internet, facilitating inter-domain routing. History of BGP. BGP was first defined in 1989 as BGP-1 and has evolved through several versions. The current version BGP-4 was introduced in 1994 and includes classless inter-domain routing. BGP has undergone multiple updates to enhance security and enhance in routing, and the diagram has been provided for the BGP understanding. Now let us discuss about the key concepts of BGP. An autonomous system is a collection of IP networks and routers under a single technical administration. BGP operates using a path vector mechanism to maintain the path information. The protocol uses attributes to determine the best path for data transmission. AS2, AS1 and BCP route updates. BCP peers exchange reachability information, and a diagram has been provided for understanding the concepts of BGP. BGP operation. BGP establishes a peer connection between routers using a TCP connection. It uses an open update notification and keep alive message for communication. Each BGP router maintains a routing table that lists all known networks, and the diagram of showing BGP operation has been provided here. BGP attributes. BGP uses several attributes to influence routing decisions, including AS path and next hop. The local preferences attributes indicates the preferred exit point from the AS. The multi-exit discriminator helps to influence the choice of entry points into an AS. BGP attributes. Well-known, mandatory next hop, AS path origin. Discretionary, local preferences atomic aggregate, and optional transitive non-transitive transitive aggregator community extended communities, non-transitive MED originator ID clustered list, MP reach, MP unreached. Route selection process. BGP selects routes based on a series of criteria, starting with highest local preference. If local preference is equal, BGP prefers routes with the shortest AS path. BGP will also consider next stop reachability and other attributes in its decision making. And the diagram of route selection process has been provided here. Types of BGP. External BGP, eBGP, is used for routing between different autonomous systems. Internal BGP, IBGP, is used for routing within the same autonomous system. BGP can operate between uh, both single-homed and multi-homed configuration. Autonomous System 1, Autonomous System 2, and there is a connection between Autonomous 1 and Autonomous 2. BGP security concerns. BGP is susceptible to various attacks, including route hijacking and prefix spoofing. The lack of built-in authentication in BGP makes it vulnerable to malicious activities. Security measures such as resource public key infrastructure have been proposed. RIB. BGP and CIDR. Classless inter-domain routing is called as CIDR, allows for more efficient IP address usage. BGP supports CIDR by enabling the advertisement of IP address blocks of various sizes. CIDR helps to reduce the size of routing tables in the global internet are route 1, route 2, route 3, route 4, and it is connected to route 5 and route 6. In route 5, route 1, route 2, route 3 and route 4 have been connected and it is passed through route 6, and this is known as the diagrammatic representation of CIDR. BGP route aggregation. Route aggregation is a process of combining multiple IP routes into a single advertisement. This reduces the number of routes entries in BGP tables, enhancing performance. Proper aggregation helps minimizing the impact of routing changes on the network. Route aggregation router. Route 1, Route 2, Route 3, Route 4 and Route 5. And from Route 1 to Route 2 there is a connection, and from Route 2 to Route 3 there is a connection, and from Route 2 to Route 3 there is a connection, and from Route 2 to Route 5 there is a connection. This is known as route aggregation, router diagrammatic representation. BGP peering. BGP peers establish a session to exchange routing information. Peering can be established through different types of connections, including direct and indirect links. Proper configuration of peering session is critical for effective route propagation, and the diagrammatic representation of BGP peering has been provided here. BGP route update mechanics. BGP sends incremental updates to its peer rather than full routing tables. This reduces bandwidth consumption and speeds of convergence time. BGP updates include withdrawal routes and new advertisement for active routes. And the diagrammatic representation of BGP route update mechanism has been provided here. We can refer this. BGP route reflection. Route reflection is a method to reduce the number of IBGP connections needed. IBGP stands for internal BGP connections needed. Route reflex allows routers to share routing information without a full mesh configuration. This simulates the network design and reduces overhead in large networks. And the route received from client is from cluster, and route received from non-client cluster. The diagrammatic representation of BGP route reflection has been provided here. BGP confederation. Confederation also are a way to divide an AS into smaller, more manageable segments. Each segment appears as a separate AS to external BGP peers. This approach helps to optimize routing within large organization. BGP confederation. BGP confederation AS100, AS10, AS20, AS200, AS200. Route 2 to route 3 there is a connection, and from route 3 to route 4 there is a connection, and from route 4 to route 5 there is a connection, and from route 1 to route 2 there is a connection, and from route 5 to route 6 there is a connection. BGP and traffic engineering. BGP can be used for traffic engineering to optimize the flow of data. Network operators can manipulate BGP attributes to control traffic paths. This allows for better resource utilization and improved network performance. And the diagrammatic representation of BGP and traffic engineering has been provided here. Monitoring BGP. Monitoring BGP session is essential for maintaining network stability and performance. Network monitoring tools can provide insights into BGP route changes and anomalies. Regular monitoring helps to detect and mitigate potential issues quickly. BGP plays a crucial role in cloud networking, facilitating connectivity between services. Many cloud services providers use BGP for redundancy and load balancing. Understanding BGP is essential for architects designing cloud-based technology or cloud-based networks. Future of BGP. The future of BGP may involve enhanced security features and better scalability. Ongoing research aims to address the vulnerabilities and limitations of the protocol. New protocols and techniques may emerge to complement or replace BGP in certain contexts. And the future of BGP diagram has been provided here, and we can refer this. By seeing this, we will get an idea of how BGP works in the future. Summary of BGP. BGP is a fundamental protocol for inter-domain routing on the Internet. Understanding its operations, attributes, and security concerns is vital for network professionals. Continuous advancement and best practices are necessary to ensure BGP's effectiveness. BGP neighboring states. A BGP peer, also known as BGP neighbor, is a specific term that is used to BGP speakers that have established a neighbors relationship. Any two routers that have formed a TCP connections to exchange BGP routing information are called peers or neighbors. BGP starts its operation when neighbors are statistically defined using the neighbor command. External BGP. When a BGP neighbors belongs to different autonomous system, they are called as eBGP. eBGP neighbors by default needed to be directly connected. Internal BGP. IGBP refers to the presence of BGP neighbors within the same as. The neighbors do not have to be directly connected because they can be reached through an IGP. Conclusion. BGP remains the backbone of Internet routing and is essential for data communication. As the Internet evolves, BGP will continue to adapt to new technologies and challenges. Knowledge of BGP is crucial for anyone involved in network design and management. Thank you for watching this video.